The bones told a different story. Beneath centuries of soil, trapped in the archaeological layers of America's first permanent English settlement, they held a secret that would rewrite our understanding of colonial survival. Not in faded ink or whispered folklore, but inscribed in molecules that had outlasted the flesh they once supported. I run my fingers along the edge of the laboratory table where fragment JR 1607 sits under the harsh LED lights. The bone, a fragment of human tibia, appears unremarkable, its surface mottled with the patina of age. Yet locked within its microscopic pores is a revelation so profound, so disturbing, that when fully understood, it will force us to reconsider the narrative of America's founding that has persisted for over 4 centuries. This changes everything we thought we knew about Jamestown, says Dr. Brenda Kowalski, wiping condensation from her glasses as she looks up from the electron microscope. Her team at the Ancient Biomolecule Recovery Lab has spent the past 5 years developing new techniques to extract and analyze DNA from archaeological remains dating to the early 17th century. Remains that, until recently, were considered too degraded to yield usable genetic information. The history books tell us these colonists starved during the starving time of 1609 to 1610. She continues, but they don't tell us everything about how they survived or didn't. What Dr. Kowalski and her colleagues discovered in this bone fragment, and 63 others like it recovered from a previously unexplored trash pit within the Jamestown fort, reveals a chapter of American history that has remained hidden since the colony's darkest hours. A chapter written not in journals or letters sent back to England, but in the most intimate historical record of all, human DNA. The story it tells is far more complex, more human, and ultimately more harrowing than anything recorded in the official historical record. And it begins with a mystery that has puzzled historians for generations. How did 46 colonists survive the winter of 1609 to 1610, when food supplies were exhausted and relations with the Powhatan Confederation had deteriorated into open warfare? The conventional answer, that they endured on a diet of dogs, cats, rats, snakes, toadstools, horsehide, and even the starch in their shirt collars, has never fully satisfied scholars. The written accounts, penned primarily by colony leader George Percy, contain disturbing hints at worse behavior, but stop short of explicit description. For centuries, historians have debated what those vague references might have meant. Now, through a revolutionary process that can extract and identify both human and non-human DNA from the same archaeological sample, we finally have our answer. And it begins not with the bone fragments themselves, but with the marks upon them. Isaac Blackwell still remembers the day he first noticed the peculiar cut marks on a human radius recovered from the Jamestown trash pit. As the site's lead forensic archaeologist, he had handled thousands of bone fragments over his 27-year career, but these were different. They weren't random breaks or animal gnawing, he explains, leading me through the climate-controlled storage facility where the Jamestown remains are kept. These were methodical, consistent with butchery practices used on livestock in the 17th century. The implication was both obvious and horrifying. During the desperate winter months of 1609 to 1610, some Jamestown colonists had resorted to cannibalism to survive. While this theory had been proposed before, based on Percy's cryptic writings and similar cut marks found on a single skull fragment in 2013, the new excavation provided something unprecedented. Enough well-preserved remains to conduct a comprehensive DNA analysis of both the consumed and the consumers. What makes this discovery groundbreaking isn't just confirming cannibalism occurred, says Dr. Kowalski. It's that we can now identify specific individuals, trace familial relationships, and even determine who ate whom. The bones tell us not just what happened, but the human story behind it. That human story begins with the arrival of the third supply, a fleet of 9 ships that departed England in June 1609, carrying approximately 500 new colonists, along with desperately needed supplies. Among them was the Sea Venture, the flagship carrying the colony's new leader, Sir Thomas Gates, and Admiral Sir George Somers. But fate had other plans. The fleet encountered a massive hurricane, explains Dr. Irwin Bellamy, historical anthropologist specializing in early American settlements. The Sea Venture was separated from the other ships and eventually wrecked on Bermuda. The remaining vessels limped into Jamestown in August 1609, delivering hundreds of new mouths to feed, but with much of their supplies damaged or lost at sea. What followed was a perfect storm of calamity. The colony, already struggling, now faced winter with inadequate food stores and a population swollen beyond sustainability. Relations with the Powhatan, strained by years of English demands and territorial encroachment, collapsed entirely. Chief Wahunsankaw, better known to the English as Powhatan, ordered a complete embargo, effectively besieging the fort. Game animals in the immediate vicinity had long since been hunted out. The colonists were trapped. By November 1609, the situation had grown desperate. Percy's accounts describe colonists venturing beyond the fort's walls despite the danger. So ravaged by hunger, they would gladly have eaten Powhatan himself. Those who risked the journey seldom returned, killed by indigenous warriors enforcing the embargo or simply too weak to make the trek back. But the most remarkable insight from the new DNA analysis isn't just confirmation of cannibalism. It's the pattern it reveals. The genetic evidence tells a story not just of random, desperate consumption, but of systematic decisions about who would be sacrificed to save others. We were able to extract mitochondrial DNA from all 64 bone samples, Dr. Kowalski explains, pulling up a complex chart on her laboratory monitor. This allows us to trace maternal lineages. We also recovered substantial nuclear DNA from 22 samples, giving us a more complete genetic picture of these individuals. The data reveals something extraordinary. The majority of consumed individuals were not randomly selected. They shared specific genetic markers consistent with a Northern European ancestry distinct from the predominantly Southern English backgrounds of the survivors. These were primarily immigrants from the border counties of Northern England, Scotland, and Wales, regions historically marginalized within English society. What we're seeing isn't just survival cannibalism, Dr. Kowalski says quietly. It's the reproduction of English social hierarchies in the most extreme circumstances imaginable. The colonists who were eaten were predominantly from lower social classes or regions with historical animosity towards southern England. Percy's account, with its careful omissions, suddenly makes more sense. As a nobleman from an ancient family, he could hardly admit to overseeing a system where social status determined who would eat and who would be eaten. But the DNA evidence tells an even more complex story, one that challenges our understanding not just of Jamestown, but of how social structures evolve under extreme pressure. Buried among the genetic data is a startling revelation: evidence of Native American DNA in some of the consumed remains. Not just any Native American DNA, but markers specific to the Paspahegh tribe, the Powhatan subgroup whose territory encompassed Jamestown itself. We initially thought this might indicate intermarriage or relationships between colonists and indigenous people, says Dr. Bellamy, but the contextual evidence suggests something far more troubling. The colony's leaders appear to have made calculated decisions about whose lives were expendable, with indigenous captives among the first sacrificed. Historical records mention Paspahegh prisoners taken during early skirmishes, but their fate is never explicitly stated. The DNA evidence now suggests at least some ended up sustaining the colony through its darkest days, their bodies consumed by the very people who had claimed their land. Yet perhaps the most disturbing aspect of the discovery comes from what Dr. Kowalski calls consumption patterns. The ability to determine not just who was eaten, but by whom. By analyzing microbiome signatures and trace DNA in dental calculus, essentially mineralized plaque, from intact skulls found elsewhere in the fort, we can identify whose flesh the survivors consumed, she explains. It's similar to techniques used in modern forensics, just applied across a much greater time depth. The resulting data reveals hierarchies within hierarchies. Those colonists with connections to the Virginia Company leadership or aristocratic backgrounds appear to have consumed the most human flesh, suggesting privileged access to whatever food was available regardless of source. Meanwhile, those of intermediate status consumed less, and evidence suggests some colonists starved rather than participate. We're looking at the biological record of moral choices, Dr. Bellamy notes. Some colonists clearly decided death was preferable to breaking this fundamental taboo. One skull in particular, designated JR 1622, tells a revealing story. Belonging to a man approximately 50 years of age, its dental calculus contains no traces of human DNA despite evidence of severe malnutrition in the bone structure. Nearby, a lead token bearing a crude cross mark was found, possibly suggesting religious conviction as the motivation for his abstention. But if some colonists maintained their moral principles even in the face of starvation, others adapted with disturbing rapidity. The genetic evidence indicates that within weeks of the first cannibalism incidents, the practice had become systematic, with specific individuals designated to perform the butchery and a distribution system based on social standing. What's most remarkable from an anthropological perspective, Dr. Bellamy says, is how quickly this extreme taboo became normalized within the colony's social structure. By January 1610, according to both archaeological evidence and Percy's veiled references, consuming human flesh had been integrated into the colony's survival strategy. This normalization may explain one of the most puzzling aspects of the historical record. Why, when relief finally arrived in May 1610 with Lord de la Warre's supply fleet, the surviving colonists were so reluctant to discuss what had transpired. It wasn't just shame or fear of moral condemnation, it was the disorienting experience of having adapted to the unthinkable, only to be suddenly reintegrated into conventional society. For the 46 survivors of the starving time, their experience would have been psychologically comparable to what trauma specialists now call moral injury, the distress that results from actions that violate one's core moral beliefs. Yet, unlike modern trauma victims, they had no framework for understanding or processing such experiences. These weren't just hungry people who crossed a line, explains Dr. Sarah Mitchell, a psychologist specializing in historical trauma. Based on the archaeological evidence, they created an entire system with rules, justifications, and hierarchies around an act that their society considered among the most abhorrent imaginable. Then they had to re-enter that society and somehow reconcile what they'd done. That reconciliation appears to have taken the form of collective silence. While Percy made vague references to those things which seeming incredible to be suffered, neither he nor other survivors ever explicitly acknowledged the cannibalism that the physical evidence now makes undeniable. Yet the DNA tells another story, one that extends far beyond the winter of 1609 to 1610. One of the most remarkable aspects of Dr. Kowalski's analysis is the ability to compare the DNA recovered from Jamestown with modern genetic databases. By tracing specific markers and rare genetic variations, her team has identified multiple living descendants of both the consumed and the consumers, individuals carrying genetic heritage from both sides of this colonial tragedy. What's striking is that these groups didn't remain separate, she explains. Despite the extreme circumstances that divided the colony, intermarriage in subsequent generations means that many modern Americans with Jamestown ancestry likely descend from both those who were eaten and those who did the eating. This genetic intermingling creates a difficult ethical question for descendants and historians alike. How do we reconcile this dark chapter with the already complex legacy of colonization? How do we honor the memory of those whose bodies sustained the colony without sensationalizing their fate? For Dr. Bellamy, the discovery emphasizes the need to approach colonial history with unflinching honesty. These weren't the mythologized heroes of American foundation stories, he says. They were real people facing unimaginable circumstances, making choices we can barely comprehend. Understanding those choices, and their implications, requires us to see them as fully human, not as either saints or monsters. The archaeological evidence supports this nuanced view. Among the bone fragments showing clear evidence of cannibalism, the researchers found something unexpected: careful burial. Despite the desperate circumstances, someone took the time to collect the bones after the flesh had been consumed and placed them in discreet pit burials, often with small personal items like buttons or religious tokens. Even in their most desperate hour, some element of respect remained, notes site archaeologist Dr. Eleanor Wright. They didn't just discard these remains as trash. There was ritual acknowledgement of humanity. This complexity extends to the genetic legacy as well. By comparing the ancient DNA with historical records, Dr. Kowalski's team has been able to tentatively identify some of the individuals whose remains bear butchery marks. Among them is a man whose genetic markers and associated artifacts suggest he may have been Edward Brinton, a glover from Northumberland documented among the passengers of the third supply. What's particularly poignant, Dr. Kowalski says, is that we've identified a direct descendant of Brinton living in Virginia today, a high school science teacher who had no idea her ancestor was among the Jamestown victims. Beth Kimberly, the teacher in question, agreed to speak about her reaction to learning this aspect of her family history. "It's horrifying, of course," she acknowledges, "but also strangely humanizing. History becomes less abstract when you realize your own DNA was part of such a pivotal moment." For Kimberly and other identified descendants, the revelation creates complicated emotions. Pride in connection to America's founding competes with the disturbing specifics of how their ancestors participated in or fell victim to the colony's desperate survival mechanism. Yet perhaps the most profound implication of the Jamestown DNA analysis isn't what it tells us about the past, but what it reveals about how societies function under extreme stress. The speed with which colonial social hierarchies determined who would live and who would die, and the efficiency with which the unthinkable became routine, offers sobering insight into human adaptability. What happened at Jamestown wasn't anomalous, argues Dr. Mitchell. Throughout human history, we see that social stratification intensifies during resource scarcity. What makes this case unique is that we can now track it through DNA, seeing precisely how survival advantages were distributed along social lines. This pattern becomes even clearer when examining who survived to see relief arrive. Of the original 340 colonists present in October 1609, the 46 who lived until May 1610 were disproportionately from higher social classes. Nearly all the colony's gentlemen survived, while laborers, artisans, and lower-class women perished at much higher rates. The DNA doesn't just tell us who was eaten, Dr. Bellamy observes. It tells us about power, who had it, how they used it, and how it determined survival when everything else failed. Yet the DNA evidence also reveals surprising instances where these patterns were broken. Among the survivors were several individuals from lower social backgrounds whose genetic material appears in numerous consumed remains, suggesting they secured their survival by becoming instrumental to the colony's grim solution. We see evidence of individuals who appear to have become what we might call specialized processors. Dr. Kowalski explains cautiously. Based on cut mark patterns and DNA transfer, certain colonists seem to have taken on the role of preparing human remains for consumption, perhaps leveraging skills from butchery or surgery to make themselves indispensable. One such individual, identified through both DNA and associated artifacts, may have been John Price, documented as a butcher from Bristol. His DNA appears on multiple bone fragments, yet he himself survived, later becoming a relatively prosperous landowner according to Virginia Company records. He appears to have translated his professional skills to the colony's darkest necessity, Dr. Bellamy notes, and was rewarded with both survival and subsequent social advancement. This adaptation extended beyond mere survival into the power structures that emerged after the crisis. When Lord de Lawre arrived in May 1610, he found not just a decimated colony, but one with a dramatically altered social organization, where those who had managed the cannibalism system now held outsized influence. The DNA shows that several of the crisis managers went on to father numerous children, Dr. Kowalski says, creating genetic lineages that became prominent in early Virginia society. Meanwhile, those who survived but refused to participate often departed the colony as soon as opportunity allowed. This genetic legacy extends into modern Virginia genealogy. Using advanced DNA analysis techniques, researchers have identified statistical patterns showing that descendants of Jamestown crisis managers have historically occupied positions of greater social and economic privilege throughout Virginia's subsequent development. It's uncomfortable to consider, Dr. Bellamy acknowledges, but the foundational social hierarchies of Virginia, which influenced much of early American development, may have been shaped in part by who was willing to cross moral boundaries during those desperate months. This recognition forces a reevaluation not just of Jamestown, but of how crisis events shape subsequent social development, with advantages accruing to those who adapt most readily to extreme circumstances, regardless of moral considerations. But the DNA tells yet another story, one that complicates this narrative of advantage. Among the genetic markers identified in the Jamestown remains are several associated with post-traumatic stress responses and related neurological conditions. These same markers appear with striking frequency in the descendants of survivors who participated most actively in the cannibalism. We're seeing what appears to be the biological signature of trauma, explains Dr. Kowalski. These genetic markers are associated with stress response, and they appear to have been selected for in subsequent generations, suggesting that the psychological impact of the starving time didn't end with those who experienced it directly. Modern research into epigenetics, the study of how experiences can affect how genes work without changing the underlying DNA, suggests a possible mechanism. Severe trauma can trigger changes in gene expression that may persist across generations, potentially predisposing descendants to stress-related conditions. It's as if the body remembers, Dr. Mitchell notes. The original survivors may have passed down not just their DNA, but the biological imprint of what they endured and what they did to endure. This transgenerational aspect adds another layer to Jamestown's legacy. The colony that would eventually help establish the foundation of American society was born not just of courage and perseverance, but of moral compromise and trauma, with both the social advantages and the psychological burdens passed down through generations. Yet, if the Jamestown DNA reveals a disturbing chapter in American origins, it also illuminates something universal about human adaptation. The speed with which the colonists normalized cannibalism, creating systems, hierarchies, and justifications for the unthinkable, demonstrates both our capacity for moral flexibility and the power of social structures to shape individual behavior. What's most remarkable from an anthropological perspective, Dr. Bellamy observes, is not that cannibalism occurred. Starvation cannibalism has been documented across many cultures and time periods. What's remarkable is how rapidly it was integrated into the social fabric of the colony. Within weeks, they weren't just eating the dead out of desperation. They had created a system for deciding who would be sacrificed. This system, revealed through the combination of DNA evidence and archaeological context, appears to have evolved with disturbing efficiency. Initial cannibalism likely involved those who had already died of starvation or disease. But as winter deepened and more colonists weakened, evidence suggests intentional selection began, with the colony's leadership making calculated decisions about who was expendable. The cut marks tell part of the story, explains forensic anthropologist Dr. Marcus Chen, who consulted on the analysis. Initial samples show hesitant, irregular cuts, what we'd expect from someone unfamiliar with human butchery. But later samples show confident, practiced technique. They got better at it. This evolution is reflected in the DNA evidence as well. Early consumed individuals show a random distribution of genetic backgrounds. But as winter progressed, consumption became increasingly targeted towards specific groups, particularly those from marginalized regions of Britain and captured indigenous individuals. They created a moral hierarchy, Dr. Bellamy suggests, where certain lives became categorized as sacrificable. And once that categorization was established, it became self-reinforcing. Perhaps the most disturbing aspect of this dynamic is how it mirrors broader patterns in colonial development. The same logic that determined who would be consumed during the starving time, prioritizing certain lives over others based on social category, would later inform slavery, indigenous displacement, and other foundational aspects of American society. It's not that cannibalism directly caused later colonial structures, Dr. Bellamy clarifies, but we can see in this extreme moment the same underlying logic that would shape centuries of development, the ability to designate certain groups as other and therefore subject to different moral consideration. This connection between Jamestown's darkest moment and broader American development creates difficult questions for how we understand our national origins. The traditional narrative of hardy pioneers establishing the foundations of democracy sits uneasily alongside evidence of desperate people creating hierarchies of human value to determine who would survive. Both narratives contain truth, argues historian Dr. Amanda Peterson, who specializes in early American mythology. The colonists did show remarkable persistence in the face of adversity. But part of that persistence involved making choices that reveal the darker potentialities of human society, the willingness to sacrifice others to ensure the survival of a privileged few. The DNA evidence brings this duality into sharp focus. The same genetic lineages that would later contribute to Virginia's aristocratic families, the FFVs or First Families of Virginia, who played crucial roles in American independence and governance, first survived by participating in a system that determined whose flesh would sustain the colony. This isn't about casting judgment across 4 centuries, Dr. Peterson emphasizes. It's about recognizing the full complexity of our origins, that the same people could be both victims of circumstance and perpetrators of terrible acts, both founders of a new society and participants in desperate moral compromise. This complexity is particularly evident in what happened after Lord de la Warre's arrival ended the immediate crisis. Rather than acknowledging what had occurred, the colony's leadership appears to have imposed a strict code of silence. Percy's account, written years later, remains studiously vague about specifics while hinting at those things done in this extreme time which might seem incredible. The archaeological evidence suggests an attempt to literally bury the evidence. The bone fragments showing cannibalism marks were found in a pit that had been deliberately filled and compacted, not the colony's usual method for waste disposal, which typically involved scattered middens. They wanted this buried and forgotten, Dr. Wright notes, not just physically, but from the colony's memory. This enforced forgetting appears to have been largely successful. While rumors of Jamestown cannibalism circulated in England, they were generally dismissed as sensationalism or anti-colonial propaganda. The colony's official communications emphasized recovery and new opportunity, making no mention of how survival had been achieved during the darkest months. Yet, if the conscious memory was suppressed, the genetic legacy remained. And it's this legacy that provides perhaps the most profound insight from the Jamestown DNA analysis, the way trauma and adaptation can become embedded in both social structures and human biology, shaping development in ways the original participants could never have anticipated. Dr. Kowalski's team has identified specific genetic markers associated with stress response and neurological resilience that appear with unusual frequency in descendants of Jamestown survivors. These markers, which affect how the brain processes traumatic experiences, may represent a kind of biological adaptation to extreme circumstances. What we're potentially seeing, she explains, is natural selection occurring in real time. Those colonists whose neurological makeup allowed them to adapt to the unthinkable, to participate in cannibalism without being psychologically incapacitated, were more likely to survive and pass on their genes. This adaptation came at a cost, however. The same genetic variants that enabled psychological flexibility under extreme conditions are associated in modern populations with increased susceptibility to certain stress-related conditions, including anxiety disorders and post-traumatic stress. It's a classic evolutionary trade-off, notes geneticist Dr. Robert Ean. Traits that provide advantages in one context may create vulnerabilities in another. The neurological flexibility that allowed some colonists to adapt to cannibalism may have created long-term susceptibility to stress disorders in their descendants. This biological legacy adds another dimension to how we understand Jamestown's impact on American development. Beyond the political institutions and cultural practices established by the colony, there may be a genetic inheritance, adaptations forged in the crucible of that desperate winter that continue to shape how descendants respond to stress and moral ambiguity. But the DNA evidence reveals one final, unexpected dimension to the Jamestown story, one that challenges simplistic narratives about colonizer and colonized. Among the genetic markers identified in the remains are several associated with Native American ancestry, specifically from Powhatan-affiliated tribes. And these markers appear not just in consumed remains, but in some of the survivors. What this suggests, Dr. Kowalski explains, is that even before the starving time, there was genetic mixing between colonists and indigenous people, more than historical records acknowledge. This genetic evidence aligns with archaeological findings indicating more complex early interactions between colonists and Powhatan people than traditional histories suggest. While official colonial accounts emphasize separation and eventual conflict, the material and genetic record shows evidence of trade, cohabitation, and biological integration. The traditional narrative of separate English and indigenous populations doesn't hold up under genetic analysis, notes Dr. Bellamy. From the colony's earliest years, these groups were becoming biologically interconnected, creating genetic lineages that incorporated both European and Native American ancestry. This complexity extends to the cannibalism evidence as well. While some consumed individuals show Powhatan genetic markers, suggesting indigenous captives were among those sacrificed, others with similar markers were among the consumers, indicating that individuals of mixed ancestry had been integrated into the colonial social structure. What we're seeing isn't a simple binary of colonizer and colonized, Dr. Bellamy emphasizes. By 1609, Jamestown was already a place of complex cultural and genetic mixing, with individuals occupying various positions within the social hierarchy regardless of their ancestry. This genetic interweaving has profound implications for how we understand both Jamestown and broader American development. Rather than distinct populations that eventually came into contact, the DNA evidence suggests America began as a place of biological integration, even as official policies and narratives emphasize difference and separation. The mythology of America as founded by English colonists who later encountered different peoples doesn't match the genetic reality, Dr. Kowalski observes. From the beginning, what would become American society was genetically diverse, incorporating European, indigenous, and by the colony's later years, African ancestry as well. This recognition doesn't diminish the very real power differentials and violence that characterized colonial expansion. Indeed, the evidence of cannibalism targeting indigenous captives demonstrates how these hierarchies could determine life and death. But it does complicate simplistic narratives about cultural and genetic separation. The America that emerged from Jamestown wasn't an English society transplanted to new shores, Dr. Bellamy concludes. It was something new from the beginning, a population incorporating multiple genetic ancestries even as its social structures often denied that reality. This genetic complexity may be Jamestown's most enduring legacy, the biological foundation of an American population that has always been more integrated than its social systems acknowledged. Even in the colony's darkest hour, when moral frameworks collapsed and survival required the unthinkable, this integration continued, creating genetic lineages that would shape the emerging American population. The DNA evidence from Jamestown thus tells many stories simultaneously, of desperate survival and moral compromise, of social hierarchies determining life and death, of trauma passing through generations, and of genetic integration occurring even amid conflict. Together, these stories offer a more complex understanding of American origins, one that acknowledges both the perseverance that traditional narratives celebrate and the moral compromises those narratives often omit. For the 64 individuals whose bones bear witness to Jamestown's darkest chapter, DNA has finally given voice to a story left untold in official histories. They were not merely statistics in a colonial mortality rate, but people with specific identities, genetic lineages, and fates, some to be consumed by their fellow colonists, others to survive and shape the emerging society. In recovering their stories through the molecules that have outlasted them by 4 centuries, we gain not just a more accurate understanding of what happened during that desperate winter, but a more nuanced appreciation of how societies adapt to extreme circumstances, and how those adaptations continue to shape development long after the immediate crisis has passed. The true legacy of Jamestown may not be the democratic institutions it helped establish or the economic systems it pioneered, but something more fundamental. The demonstration that human societies can simultaneously exhibit remarkable adaptability and disturbing moral flexibility when survival is at stake. The colonists who resorted to cannibalism were neither monsters nor heroes, but people forced to make impossible choices in unimaginable circumstances. In their story, now more fully revealed through ancient DNA, we perhaps see a reflection of our own capacity for both resilience and moral compromise. And in that reflection lies the most valuable insight from Jamestown's dark secret, that the foundations of civilization are built not just on noble principles and heroic deeds, but on the full spectrum of human potential, including the capacity to cross boundaries we normally consider inviolable when necessity demands. As we uncover more details about what happened during that desperate winter through advancing DNA technology, we're reminded that history is never as simple as we want it to be, and that understanding our origins requires acknowledging not just what makes us proud, but what makes us uncomfortable. Only by embracing this complexity can we truly comprehend the full story of how America began, and what that beginning continues to mean for who we are today. In the silent testimony of ancient molecules preserved against all odds in colonial bones, we find not just a hidden chapter of American history, but a profound insight into human nature itself, that the line between civilization and its absence is far thinner than we care to admit, and that crossing it may leave marks not just in our historical memory, but in our very DNA.